My project is on battery technology and the direction it's heading. First, let's start with how a battery works. All batteries contain these three elements: the anode, which is negatively charged, the cathode, which is positively charged, and an electrolyte, or a separator, to keep the two electrodes from reacting directly with each other. The electrons flow from the anode through some sort of load, be it a light bulb, a motor, or whatever it is you need to power, to the cathode. Lithium-ion batteries are the most powerful types of batteries on the market today. As you can see, they pretty much look like the traditional types of batteries we all know and love. The only difference is that the lithium-ion batteries have been fine-tuned and are a lot more powerful than traditional batteries. Lithium cobalt is used for the cathode. Lithium is the smallest, most reactive element, giving it a very large charge density. Carbon is used for the cathode. Carbon is cheap to produce and relatively unreactive, which creates a large potential difference between the anode and the cathode. Fuel cells also have an anode, a cathode, and an electrolyte. Hydrogen enters at the anode, and a reaction strips them of their electrons. As the electrons travel through the circuit, the hydrogen ions travel through the electrolyte until it reaches the cathode and combines with the oxygen and the electrons it lost to create water. The main difference between fuel cells and batteries are that batteries keep all their reactants and products contained internally, while fuel cells obtain their reactions externally and release their products into the environment. As you can see, the energy density which fuel cells can achieve is far greater than batteries. In the graph, the blue bars represent the batteries or fuel cells with the lowest output, and the red bars represent those with the highest output. However, there's a catch. The power density of fuel cells are still really low. Contrary to popular belief, energy and power are not the same thing. Power is the rate at which energy is used. So the use of fuel cells in machines that require a lot of power, like cars, is still impractical at the moment. The battery hasn't changed much since Alessandro Volta first invented it in 1800. They may have gotten smaller and more efficient, but overall they are pretty much the same. And the same is true for fuel cells, which was introduced to the world in 1839. Now, paper batteries, on the other hand, have only been recently discovered. They consist of paper, any ionic liquid, a lithium oxide coating, and carbon nanotubes. Carbon nanotubes are exactly what they sound like: extremely tiny, long tubes of carbon. What makes paper batteries great is that instead of having several separate pieces that make it up, all the parts are integrated into the paper, with the nanotubes as the cathode, the lithium oxide as the anode, the ionic liquid as the electrolyte, and the paper to bind it all together. Finding hard numbers for paper batteries is a little difficult because the technology is really new, but with a small amount of paper, you can achieve numbers comparable to that of fuel cells and batteries at a lot less weight. Therefore, it stands to reason that the energy and power densities are much greater, and to increase overall power and energy, you simply need to use more paper. The only thing to do now is to find a cheap way to mass produce the carbon nanotubes, but I have high hopes for this innovation in energy storage. And these are the sources I used for this project.